Hi everyone, today we're going to do a little refresher on limits. Limits are going to be the first topic you study in calculus. So hopefully this will be a nice little bridge. Watch it now, watch it before you go back to school in the fall, up to you. So we've done limits this year talking about asymptotes, specifically horizontal asymptotes. So a horizontal asymptote is really talking about end behavior, so the limit as x approaches infinity or negative infinity of a function. So for example, if you have the function 1 over x, right, that kind of looks like this. With a horizontal asymptote at 0, at y equals 0, and a vertical asymptote at x equals 0. But so we can describe our end behavior of this function by saying the limit or lim as x approaches infinity of f of x of 1 over x equals 0, right? What is the y value approaching as x is approaching positive infinity? The y value is approaching 0. And then what's the limit as x approaches negative infinity of f of x? This is also 0. Right, it's also the y value is approaching 0 as we approach negative infinity in the x direction. So instead of using limit notation to just describe end behavior, describe a horizontal asymptote, we can also use it to describe different limits or other places where we don't actually ever get to our answer. Like so here, the limit as x approaches infinity will never actually reach there, so the limit is where our y value is getting closer and closer and closer to, but not actually getting to, and that happens in other functions as well. Let's say we have this function. I just made it up. It's a piecewise function. I don't know what equation it is. We'll call it g of x. Okay? If I'm curious about the x value negative 2 right here, there are 3 different points where my y value, kind of exists. So if I want to talk about the different limits as we're approaching negative 2, if I want to talk about the y value at negative 2, there's a couple different ways that I can describe it, depending on what I'm looking for. So I can say the limit as x approaches negative 2 of g of x equals something, some y value. But the limit as x approaches negative 2, as x approaches negative 2 on my curve as I'm kind of riding this roller coaster, it's at 1 for one part of the equation, but if I were to come the other way, it's at 3 for another part of the equation. As x gets closer and closer and closer to negative 2, y is getting closer and closer and closer to either 3 or 1, depending on what part of the graph I'm traveling on. So for limits, we have to describe which side we're approaching from. So if I say the limit as x approaches negative 2 with a little plus sign in the corner, so that means it's coming from the right, from the side with the positive numbers. So the limit as x approaches negative 2 from the right of g of x of this function is going to be 3. Right? The y value as I'm traveling towards negative 2 on my function from the right-hand side, the y value is getting closer and closer and closer to 3. I can also say the limit as x approaches negative 2 from the left with a little negative sign in the corner, from the side with the negative numbers of g of x equals 1, right? As I'm traveling from the left, from the side with the negative numbers along my graph, towards x is getting negative 2, x is getting closer and closer and closer to negative 2, but not actually reaching it because we have a hole here, my y value is getting closer and closer and closer to 1. But I also have an actual defined point for x equals negative 2. So the difference is f of
My
negative
bad,
2,
there should
the
be g of
function
negative 2, because our
value of the
function is called
y
g.
value
What is
at
g of
x is
negative
equal
2?
to negative 2 equals negative 1. So we have three different ways to describe our y value at x is negative 2. The limit as x approaches negative 2, as it gets closer and closer to negative 2, it can't actually reach there if I'm coming from the right because there's a hole here, so it never actually has a value at that point. But it's getting closer and closer and closer to 3. The limit as x approaches negative 2 from the left is getting closer and closer and closer to 1. But the actual value, the actual defined point at x equals negative 2 for this function is negative 1, where it's actually filled in. So here's a function. I labeled it h of x. And this x value is a, and then these are the three y values that are of interest, p, q, and r. So try answering these questions. What is the limit as x approaches a? Plus sign. What does that mean? Limit as x approaches a with a negative sign. What does that mean? And f of a.
Again, it should be h of a. I did it again. Oh no.
So the limit as x approaches a with a plus sign means it's coming from the right side, from the side with positive numbers. So I'm coming this way towards a. So the limit as x approaches a from the right is going to be r, whatever that value is. The limit as x approaches a with a negative sign from the side with the left-hand side, from the side with the negative numbers, it's going to be as I'm approaching a, I'm approaching a, I'm approaching a, my y is approaching q. And what is the actual value? What is the function of a? What is f of a? P. Thanks for tuning in. Let me know if you have any questions. There's a lot more stuff you can do with limits that you'll find out in calculus, but this is just a little recap of some of the notation that we've done earlier and some uses for limits.